We have waited long enough, so it's 6:45 already. And so we're going to just continue. I want to say two things before I proceed. And I'm saying it to those in attendance because this will be posted online and students will be informed, and I'll put it in writing too. I can see quite a bit of skipping of the homework assignments, maybe because some of you do not understand how to do them. I will open all the assignments so that those who are missing assignments can complete them before the end of March. So I'll open all the assignments, all the past assignments for another 4 weeks. Now, I want to make very, very clear that all these assignments must be done before you can get a grade for the class. If you're missing an assignment, you will not get a grade. And if you fail the class, then that means you have to repeat the class. I don't think that these assignments are difficult. So today, what I'm going to do for today is I'm going to go through some of the assignments. I'm going to go back to the machine assignment. I'll go back to the assignment for test of hypothesis. The machine assignment is about confidence intervals. I'll go through doing confidence intervals by hand. In that way, you will all see how it is done, and it has to be done right. Okay. And I will also go through hypothesis tests for two populations by hand so that you can also see how it is done. And so there'll be no excuses for not doing the assignments and passing this class. And I don't see any other way, but I will reopen the assignments for those who are missing them to redo them. To be able to submit them before the end of March, and then we will continue. And for that reason, I will skip today's topic, which is analysis of variance. And as you can see, we are beginning to we're beginning to get away from some of the topics that you dealt with in statistics 1. We're now beginning to actually move to the next stage, which is statistics 2. Incidentally, it takes about 5 weeks because I want to be able to review the things that you have done previously, so as to lay the foundation for what we're going to do for this class that makes this class special. Now, having said that, I will do a second office hour on Thursday for this class, okay? I'm going to do second office hour on Thursday in order to do what we were supposed to do today. So I will urge everybody to please come because we're now moving to higher level topics. The higher level topics are the topics that make this class higher than ECON356 or higher than any introductory statistics class that you did. Okay, so we're now beginning to get into that, into those higher level topics, which are different. So I'm going to do that office hour on Thursday, this coming Thursday. Now, if it's Thursday is not good for the majority of the class, I'm going to give the option to do it on Wednesday. In that way, there will be no excuse. Or might even, if it matters that much, I might even give the option of a Saturday, okay? Just to make sure that we do not have an excuse not to come. So I'm going to give that option. So I'll make it special for this Saturday, in which case I will cancel my office hour for Thursday and do it on Saturday to make sure that we are able to really begin to step up. All right. Somebody has a question.
What if I'm fine with Thursday and I'm not available for Saturday? Can I just watch the video you put up?
If you're not available on Thursday, on Saturday.
I mean Saturday, yeah.
Okay, if you're not available on Saturday, and I do it on Thursday, excuse me, and I do it on Saturday, of course, I always post the video.
Okay, yeah.
I always post the video, so you have nothing to lose. But I'm just going to give that option.
All right.
Majority, if more students choose Saturday, then I'll do it on Saturday. If more students choose Thursday, I'll do it on Thursday. If more students choose Wednesday, then I'll do it on Wednesday. But I just want to be sure that we're not skipping, okay? Because all the students in this class are financial economics majors. And majors are really the top students in terms of GPA and performance, and also in getting jobs. So you don't want to go there and change the story or cause the story to look different from what it is supposed to be or what it has been. All right. So having said that, I'm going to go back and we will talk about the machine the confidence interval, because I see a lot of students skip the confidence intervals problem. Okay, and I need for us to be able to do the right thing for this class. So for now, I'm going to. So I am back. So let's see where we're going to begin. I'm going to share my screen. Okay, I'll share my screen. I'm going to go through a confidence interval problem. Are you seeing my screen? Hello?
Yes.
Okay, I need to hear responses so that I'm not just going to keep talking. I don't know whether you are seeing what I'm doing or you're not seeing what I am doing. Okay. And the reason I'm saying this is that at some point I heard the students in a conversation saying, I'm going so fast. Well, if I'm going fast, talk to me. You know what I said? If I'm going fast, talk to me. There's something. Tell me to slow down, or tell me I need to understand what you're doing. This is what I do not understand. And then we will proceed to clarify things. But if you're not saying anything, I will take it that you are catching up with what I'm doing. Okay. I'm going to take a simple problem. And the simple problem is that I'm going to calculate a confidence interval for the average age of houses in this neighborhood. You can see the data on age of houses in this neighborhood. So I'm going to do a confidence interval, and I need for you to use this method to do the confidence interval problem if you have not already done it. And if you have done it and I have graded it and you want to redo it, then ask me to open it for you, because I'm going to reopen all the assignments. And I'll reopen it for you and you can redo it, okay? So how do you calculate confidence interval? I'm going to save that file. Okay. I'm going to save that file and go through the process of confidence intervals. All right. So I will share a different file. And the file that I'm going to share is a PowerPoint slide that we're going to be working off of. So we're going to do confidence interval, and I'm going to do the confidence interval on the age of houses. So what is the purpose of confidence interval? So let's talk about the purpose of confidence interval. Okay. What is the problem? What is the problem we have? The problem we have, and the reason why we do our confidence intervals and reason for confidence intervals. All right. The problem is that we have a population. Okay. For example, houses in a neighborhood. Okay. We have a population of houses in a neighborhood. All right. Number two, we do not know the true average age of the houses in the neighborhood. We do not know the true average age of houses in the neighborhood. We only have a sample, and our objective is to use information from the sample to reach some conclusions or make inferences about the true average age. That is what confidence interval is about. Okay, that is what confidence interval is about. Okay, so how do we go about it? How do we go about using information from the sample to reach some conclusions about the true average age of houses in the neighborhood? Now, what is the process? Okay. You can say steps in confidence interval. All right. One is, of course, we collect the sample. Okay. We'll calculate the sample mean. Okay. We'll calculate the sample standard deviation. All right. We state our confidence level. Right. We select or determine the critical Z value for our estimate. All right. So these are the steps. These are the steps. Now I'm going to begin by saying, okay, what is the confidence level we're going to use? Okay. We're going to do, say, and for example, we're going to do, say, a 98% confidence interval. All right. And again, this is something that we already did in statistics 1. And so the critical Z value for a confidence interval of 98% is 2.33. Okay. Again, you should have known how to do this, but I'm just going to state it right here. Okay. We'll collect a sample. The sample has to be a particular size. Size equals n. Okay. So in this case, we're going to look at a sample of about 30, 33, 34, whatever. Okay. So I'm going to now bring up some data. I'm going to calculate a sample mean, and that sample mean we'll call X bar. Okay. We'll call X bar. Okay. So we'll call the sample mean X bar. The sample standard deviation is S. All right. That is the sample standard deviation, is S. Now, so how do we establish a confidence interval? Now, there are two ways you can do this confidence interval. You can use SPSS, and before I continue, I've already requested that the college provide you a remote access to SPSS. They have not responded yet, and I'm going to raise the question again. All right. So we're going to go through the process. Like I said, we have already selected a Z star, the critical Z value. Our confidence level is going to be 98%. So now we're going to calculate the sample mean and the sample standard deviation. And then we'll follow the formula. All right. All right. So I'm going to save this. And then when we calculate the sample mean and sample standard deviation, then I will come back to this PowerPoint slide. Okay, so you see the data that I have here. Okay, everybody seeing the data?
Yes, Professor.
Okay, this is the wrong data. I'm going to pull up another one. All right, so you see my data, am I correct? Hello?
Yes, Professor, we can see.
Okay, you can see the data. So I'm going to do two calculations. I'm going to calculate the sample mean, that is sample average of the age of houses, okay? And then I'm going to calculate the sample standard deviation. You can do it easily using Excel, all right? I can do it easily using Excel. So I'm going to calculate, I'm going to use the Excel function, average. So the average here is 64.9 years, okay? And so I'm going to calculate this standard deviation. which is the sample standard deviation. Okay. Okay, the sample standard deviation is 22.616. So I'm going to write that down because I'm going to use it. All right, so let's move on. So here now, the sample mean, okay, which we call X bar. Okay. Equal to 64.9, 64.90. Okay. The sample standard deviation is S is equal to 22.616. So that's what we have. Okay. The sample size N equal to 32, or actually 31. So we have a sample size of 31. Now, the confidence interval that we establish here, and we establish Z equals to 2.33. Okay. We're doing a 98% confidence interval. Okay. And so the formula then is that our objective here is to calculate two numbers. Okay. Our objective here is to calculate two numbers. One is a lower number and the other is an upper number. And we are simply saying that we do not know the true average age of houses in this neighborhood. But with 98% confidence, we can say that the average age can go from here to there, from the lower number to the upper number. So that is our confidence level, our confidence estimate, that we don't know what the true average is, but it could be between this lower value and this upper value. And so the formula then is that, again, I'm going to insert the formula here. Okay. X bar minus Z times sigma divided by the root of n. Okay. As a matter of fact, you can say X bar plus or minus. All right. So we know what X bar plus or minus means.
Were you typing this, Professor?
Am I doing what?
Were you typing what you were saying?
I am writing it and it converts to something that is typed.
Oh, because I cannot see what she was writing.
Oh, okay. Well, there it is. Can you see it now?
No.
Oh, forgive me. Okay. I didn't even. Let me save this. What was I sharing with you then?
You're sharing the data from Excel.
Oh, okay, sorry. Okay. All right. You see what I just did?
Yes.
Okay. So this is the formula. We calculated a sample mean, which we wrote down. Okay, you saw it, and we calculated a sample standard deviation. And so I wrote it down. We have a sample size, okay? And for 98% confidence interval, the Z is 2.33. And the confidence interval is X bar plus or minus Z equals to plus or minus Z times sigma over root N, which is the sample standard deviation. Okay, so now let us now break this open, okay, which is X bar minus, and that is less than mu, which is the mean, the true population mean. Okay. Less than all right. So you can see that the true population mean is mu. Okay. Mu is the true population mean, but we don't know what the true population mean is. So we're going to estimate that the true population mean is between X bar minus Z times sigma over root N and X bar plus Z times sigma over root N, because sometimes we write this also as sigma. So I'm just going to see if I can do that. Okay. All right, you can use sigma if you want. Okay. So now I'm going to translate this into numbers. Okay. We're going to translate that into numbers. Let us see how it translates. Excuse me. Okay. Calculation. 98% confidence interval. All right. So this is the formula. Okay. This is the formula. And so X bar is 64.90 minus Z is 2.33. Okay. Are you seeing what I'm writing?
Yes, Professor.
All right. Yeah, I don't want to get you lost again. Okay. Times sigma over root N. Okay. So here we know that sigma is 22.616, 22.616 over the square root of N. See, square root of 31. Okay, which is less than. We can take that and copy it over. Okay, so this is now a plus on that side. All right, so this is the formula. And once you do this calculation, less than, maybe it's correct. All right. Reduce this, make it smaller. All right. So you can see the whole formula here, and then okay. Can somebody help us with that calculation? Can somebody help us do the calculation? Hello? Somebody helping us? I am waiting.
I'm getting it done right now, Professor.
You're doing that. Okay, that's what I want to hear. Okay, guys, like I said, sometime pretend you are in church. I want to hear the hallelujah, okay? All right. So this is 64.90 minus
9.46.
9.46. Did you do the calculation inside here?
Yeah.
Okay. Okay, so you're correct. Now you actually showing that you know how to do it in such a way that you minimize errors. And thank you for that. I hope everybody learned from what our good friend just did. Okay. And so you can see that.
Professor,
Yes.
I got 9 point. Okay, good. Just 4.6, not 4.
It's 9.46. I
Yeah.
verified it. Okay. I verified it. So you can see that on this side it's a plus. All right. And so once you do the calculation on one side, this inside calculation of z times sigma over root n, you can just move it to the other side and just change it to a plus. All right. That's how it's done. Okay. So what is the answer? The answer is very simple. Okay. 64.9 minus 9.46.
It's 54.44.
I think it's more like 55.
Oh, 55, I mean 55.
55.435. 55.435. And on the other side, we have
74.364.
74.364. Okay, so what is the meaning of this statement? What is the meaning of that statement? Very easy. Okay, the meaning of this final answer is very simple. Okay, the meaning of that final answer is very simple. It means that we have a neighborhood with a vast population of houses. When I say a vast population, a large population of houses. Okay, you cannot go and count every house. You do not have the time to count every house. But we have a sample of houses, and we can use information from that sample of houses to estimate the true population average age of the houses. And with 98% confidence, so there's a 2% chance we can be wrong, but with 98% confidence, we can say that the average age of houses in this neighborhood is between 55.44 years and 74.63 years. That's all we are saying. And I believe that everybody here can do this estimate by using Excel. Easy. Okay? Very easy. So I want everybody to go back and use the information this way, that what we have, and do the problem that has confidence interval in it. A lot of students did not do it right, and it doesn't make sense for me to award you a passing grade in ECON356 when you cannot do something like this. Now, let me be honest with you. When you go to industry, you're going to be confronted with this kind of data. And you may be the one having to do the calculations, or it's going to be done for you, but you need to be able to give it the proper interpretation. Now, this is one thing. Secondly, I've seen quite a number of our students who say they want to go to grad school. When you go to grad school, you're going to have to do this on your own. Okay? Now, this is how to do it very simply with Excel. But you can do it easier using SPSS. Okay? You can do it easier using SPSS. And I can actually, do an SPSS example for you right now so that you can see what we're doing. Okay? So for now, I'm going to save this file, and I'm going to do the same problem using SPSS. All right? But in the absence of SPSS, you can see you can do with Excel. Even if you have to break up neighborhoods, okay? You have to break up neighborhoods, and I'll show you an example. Okay. So I will stop share and pull up a data set where you have two different neighborhoods and you need to compare them. All right. Are you seeing my data set, the new Excel data set?
Yes.
Okay, what is it saying? What information does it have? Hello? What is the name of the data set?
So it has how many bedrooms, size of the houses, pool distance.
Okay. So it's the Goodyear real estate, which is what we're gonna do next when we gonna compare two neighborhoods. Now we're gonna compare two neighborhoods here, okay? Or actually two populations here. One is the population of houses that have a swimming pool, and the other is the population of houses that have a garage or don't have a garage. Okay. One, you can compare houses that have a swimming pool or do not have a swimming pool. It is very easy. Okay. Very easy. The first thing that you need to do is to sort the data. You click on data. You go on sort. You sort by pool. You sort by pool. What happens? You can see all the houses that have no pool, 0, are up there. And the houses that are labeled 1 have a swimming pool. Okay, let me make that very clear. All right. You can see the houses that have no swimming pool. There are 39 of them. And then the houses that have the swimming pool go from number 40 to number 106. Okay. And you can make it easy for yourself. So you can make it easy for yourself by breaking up the data and creating 2 data sets. All right. For example, okay, you can copy that and create for yourself a different data set. And then you go over here to the 40th data set, copy them up, cut. There you go. And so you can calculate 2 means on 2 separate positions. And you calculate a mean here, you calculate a mean there, you calculate a standard deviation here, you calculate a standard deviation there. Okay? There are different ways of solving problems so that you don't run into confusion. Okay. So I'm going to save this. Okay. I'm going to save this. All right. So now the next thing then we're going to do is we're going to try to run an SPSS data set. And I'm going to be sure. Okay. All right. So here is an SPSS data set. The SPSS data set has a data view and a variable view. We are in variable view. The variable view describes the variables. Okay. Bedrooms, number of bedrooms in the house. Size, the size of living space in square feet. Okay. Pool, does the house have a swimming pool? 0 means the house does not have a swimming pool. 1 means the house has a swimming pool. Okay. What is the distance from city in miles? What is the municipal classification? Does the house have a garage? 0 if the house has no garage, and 1 if the house has a garage. Okay. How many bathrooms in the house? What is the selling price of the house? These are the kinds of variables that we have. If you click on data view, you will see all those values. Okay, you will see the values. If the house is labeled 0, that means it has no swimming pool. If the house is labeled 1, that means it has a swimming pool. So let us do a confidence interval on the average price of houses. A confidence interval on the average price of houses. Are you seeing my SPSS data set? Hello? Are we still there?
Yes, we're here.
Are you seeing my SPSS data set?
Yes, I'm saying it, but I don't listen what's going on.
Okay.
I've never seen it like this.
You have never seen the SPSS data set like that?
I've never seen a shit like this before. So I've never seen the.
Okay, because you have not been attending the lectures. Okay.
No, I be in all of your lectures. It's just that I've never like used SPSS before.
Okay.
So yeah.
All right. Like I said, you can use SPSS, you can use Excel. You can see how we went about it in Excel. But I'm going to do a confidence interval of the price of houses using SPSS. Okay. Now, instead of calculating the mean and the standard deviation, and you go through the formula, fine and good. Okay. It's very important that you know the formula because I'm going to test everybody on knowing that formula. All right. I have an assignment that requires you to use the formula. All right. So, but in order to analyze any data in SPSS, you have to begin with analyze. Okay. Have to begin with analyze. You click analyze. To do a confidence interval, you go to compare means. Okay. You click on one sample t-test. One sample t-test. You click on it. We're trying to do a confidence interval on the selling price of houses. You can also do a confidence interval on the amount of living space. And then here, under test value, your test value is 0. You go to options, and you say 98%, okay? 98% confidence interval, that's what you want to establish. So continue, you say, okay. Once you click okay, what happens? What happens? You have your confidence interval right there. You have confidence interval for the selling price of house. You have confidence interval for what do you call it? For the size of living space, okay? The confidence interval simply shows that with 98% confidence, the average selling price of house will go from $210,000 to $231,964. That is the answer to that. Let me see if we can cut and paste it into MS Word. Copy. See what I just did? Okay. I'm going to stop share. And I will pull up. I will share with you an MS Word file. So here you have the confidence interval. You can cut out what you don't want. For example, I don't want to see this two-tailed significance. I don't want to see the degrees of freedom, but you have a confidence interval and you can give it an interpretation. And that is what I want you to cut and paste for me and tell me that this is what the confidence interval looks like. You get that? Okay. So the next thing that we're going to talk about, I'm going to pull up, I'm going to start to share again. So now you know how to do a confidence interval. Is it clear to everybody? Hello?
Yes, sir.
All right. I don't want to lose anyone. Now, the next thing we're going to do the real estate homework assignment. And now I'm going to pull up the homework problem. Okay, I'm going to pull up the homework problem and we're going to look at what it said. Okay, I'm going to pull up the real estate problem and I'm going to look at what it said for us to do. Okay, so I'm going to stop share. And I'm gonna see. Okay. Okay. Are you seeing my screen now?
Yes.
Okay. Your assignment says, what two populations or groups can you identify from the data? What two populations or groups can you identify from the data? All right. It says, set up a null and alternate hypothesis to test whether there are significant differences in size or distance from the city for two of the groups and explain their meanings in context of a practical business research or economic analysis. Then says select an appropriate level of significance and critical T or Z statistics for your test. Calculate the difference between the sample means, calculate the T or Z values for comparison, and correctly apply the decision rule to reject or not reject the null hypothesis. All right, so this is the problem you were supposed to solve, okay? Now, again, I'm gonna look at the data and I'm gonna identify two groups, okay? And I'm going to do one of the problems. I'm going to look at size. I'm going to look at size. Feel free to identify the same group as I did, but you're going to have to do the problem on distance from the city. But I'm going to look at size. All right. So I'm going to stop share, and I'll pull up the data in Excel. All right. And then after I pull up the data in Excel and we solve the problem in Excel, then we're going to solve the problem in SPSS. Or you can see how easy it is. All right. All right. So are you seeing my data set?
Yes, I do.
All right. Okay. And you can see, remember that I have split the data between the houses that have no swimming pool and the houses that have swimming pool. You can see that? Hello?
Yes.
Wait, no, yeah. Wait, swimming pool. Okay, yeah, I see it.
Okay, so you're seeing my data set. So what I did was to sort the data, and I broke the data up into two separate locations, okay? The houses that have no swimming pool, you can see the pool has the number 0, and the houses that have swimming pool, the houses have the pool, the value of pool is 1. When you have to do the problem, I ask you also to look at distance from the city, okay? So distance is here, all right? So you have to do the problem on distance, but I'll do the problem on the size of the house, all right? So very easy. How do you do a hypothesis test for two populations? Your objective is to compare the two populations and ask yourself, is there a significant difference in the average of some variable? Here, the average size of the house. That is what you're asking yourself. Okay, you're asking yourself, is there a difference in the average size of houses that have swimming pool compared to the average size of houses that have no swimming pool? That is what we're going to do. Okay, so you have the data set. I split the data into two. I'm not going to give you this split. You are going to have to do the split yourself. You're going to have to sort the data. That is part of learning. That is part of you acquiring the skill. All right. This is just what I did to solve this problem. So I'm going to stop share and then go through the process of hypothesis testing for two populations. I will share my PowerPoint slide. Okay. Hypothesis testing for two populations. The two populations we have identified are houses, house has a pool and house has no pool. And we want to compare the average price of the two types of houses. Okay. So how do we go about that? Okay. How we go about that? All right. So what is the first step is to state the null hypothesis and the alternate hypothesis. That is the first step. Okay. And how do you state the null and alternate hypothesis? I'm going to go through that. Okay. The null hypothesis is see if I can ink that equation. Are you seeing my screen? That is the null hypothesis. Mu1 minus mu2 is equal to 0. Okay? There is no significant difference in average price of houses. Okay. What is the alternate hypothesis? I'm going to copy that and modify it. And the alternate hypothesis is there is a significant difference. There is a significant difference. Okay, take note of that. Okay, there's a significant difference in the average price of houses in the two neighborhoods. That is your null hypothesis, and that is your alternate hypothesis. All right, everybody get that clear?
Yes.
All right. Okay. So now, what are the steps? Okay. The steps are the same thing as you do in a confidence interval. You select a level of significance, set up a level of confidence, select a level of significance. You calculate the average for one neighborhood, you calculate the average for the other neighborhood. You calculate the standard deviation for one neighborhood, you calculate the standard deviation for the other neighborhood. You recognize, you take note of the sample size in one neighborhood and the sample size in the other neighborhood. Okay. So let us see how we go about it. Okay, the steps in hypothesis test for two population means or averages. All right. Okay, calculate the sample mean. Okay, for group 1. Calculate the sample mean for group 2. All right. And so, what does the sample mean for group 1? Now I'm going to write it down. X1 bar all right. And the sample mean for group 2. Let's see. I'll copy that and modify it. All right. All right. So the same way you calculate the sample standard deviation. Calculate the sample standard deviation. And that is S1 and a sample standard deviation S2. So you calculate sample standard deviations for each of them. All right. And so once you do this, then you calculate a Z. You calculate a Z, and Z okay. So this is a calculated Z for hypothesis test for two populations. X1 bar minus X2 bar divided by the square root of S1 squared over N1 plus S2 squared over N2. So once you calculate this Z, you compare the Z to the critical Z. Okay, calculate Z and compare to Z star. Now, how do you get Z star? Okay, so let's move to the next stage. Okay, and I'm going to take this. So I'm going to use it next. To do what we call the decision process. So we apply decision rule. Okay. All right. So how do we do that? Now we've already said we have to select a level of significance, which we have already talked about in this class. And so I'm going to select level of significance of, say, 0.01. And the Z star for that, Z star is 2.33. So my challenge to you is to select the right Z star for your level of significance in a test. So we're going to have to work on that. The Z star here is 2.33. That's what we're going to use. Okay, but that's for a 0.01 level of significance. All right, so you figure that out. So now, how we're going to calculate X1 bar and X2 bar? So we're going to do that. I'm going to save this file, and I'm going to stop share and pull up the data set. Okay. I'm going to pull up the data set. So I'll start a new share. Remember we said, are you seeing my Excel file? Hello?
Yes.
Okay. So we're gonna compare price. So you do size. I will do price and you do size. Okay. So you can see all the houses with no pool are on the left side. Okay. And the houses with pool are on the right side. So we're gonna do the average price of houses with no pool. Okay. And there are 38 houses with no pool. So we'll calculate the average. All right. So we calculate the standard deviation. Okay. Calculate the standard deviation. And it's H2 to H39. Okay. You can see the sample mean is 202797. There's 38 houses there. 797.4. And the standard deviation is 33,705.06. All right. For the houses with pool, there are 67 houses with pool. We calculate their average. And then we'll calculate the standard deviation. It's Q2 to 268. All right. So there are 67 houses, or 67 houses. And the average is 231 for 85.1. And the standard deviation is 50, 569.34. All right. So we have the information. I wrote it down. So you are seeing my calculations. Hello, guys. I want to stop share. And I'm going to go back to our PowerPoint slides. Okay. So we have that X1 bar X1 bar is 202,797.4. Okay. S1 is standard deviation for those houses. S1 is 33,705, 33,705.06. All right. The sample mean for houses with pool, 231, 485.10. And the sample standard deviation for those houses is 5569, 5569.34. All right. The sample size N1 equal to 38, and the sample size N2 equal to 57. Okay. All right. So now we have this information. We're going to now calculate the Z and compare the Z to Z star. All right. Okay. Calculations and decision rule. All right. So X1 bar, we know what it is 202,797.4. And we're going to use the absolute value. Okay. And the other one is 231, 485.10. Okay. So we're going to use the absolute value of that. S1 is what? S1, the standard deviation for 1 is 33,705. 705.06. Yeah, I'm going to leave that there. And the standard deviation there is 569.34. Okay. All right. And N1 is 38, and N2 is 67. All right. So we're going to use the absolute value of this and then compare it to Z star. Okay. Can somebody help us with the calculation? Hello? I need help. I need help. What is the absolute value of 231,485 minus 202 minus 202,797.4. Okay. The difference is 28,687.7. Is 28,687, 28,687.7 divided by the square root of okay. Three 61,249, 361,249 plus 5,569.34 squared divided by 67 is 298,9555. Not correct. You guys are not helping now. 298,9555. Okay. And that is 5,569.34 to the power 2 over 67. 38168. 38168. 032. 106. Okay. All right. All right. So what we have is 28 28 687.7 divided by 8250 8250.065.065. And so what is the answer? 3.477. 3.477. Hello, guys. Are we still there?
Yes, yeah.
Are you following me?
Yes.
Okay, but nobody was helping me to do that math. Okay, so Z is equal to 3.477. All right, so we're now going to make our decision rule. Okay, so we have Z so we're now going to apply decision rule and decision. Apply decision rule and make a decision. Z is equal to that. Okay. Now, before we even do that, let's go back and get a hypothesis. These are the hypotheses. Okay. So Z is this. Okay. I'm going to make this a little smaller. Okay. So our decision rule is if Z is greater than or equal to Z star, we reject the null hypothesis. Okay. If Z is less than Z star, we cannot reject the null hypothesis. Okay, so the question is, our Z is 3.477. And our Z star is 2.33. Okay, so what is the implication? Is Z greater than Z star? I want to answer. Please give me an answer. Hello?
Yes.
Is Z greater than Z star?
Yes, Professor.
Okay, so do we reject the null hypothesis or do we not?
You're not rejected?
You say what?
What's the question you just asked?
The question is, if
we
Z,
reject.
we reject the null hypothesis. Can you please all speak with some confidence and be, see, I want to be sure that you are getting what I'm saying. It's a very simple thing. If Z is greater than Z star, do you reject the null hypothesis or do you not? Okay, the answer is if Z is greater than Z star, you reject the null hypothesis. If Z is less than Z star, you cannot reject the null hypothesis. So in our problem, our Z is 3.477. Our Z star is what? 2.33. What do you conclude? Do you reject or not reject the null hypothesis?
We reject.
Thank you. We reject the null hypothesis. What is the null hypothesis? The null hypothesis that we are rejecting is that there is no difference in the average price of houses. And since we reject the null hypothesis, we are concluding what? That there is a significant difference in the price of housing. You get the idea?
Yeah.
Good. So we are saying that houses that have swimming pool are more costly than houses that have no swimming pool. From our calculation here, right? Our calculation here is that houses that have swimming pool are 231,000 and houses that have no swimming pool are 202,000. So it means that these numbers are meaningful in the sense of, determining the difference. If you are not able to reject the null hypothesis, you will simply say that the difference is what? A random statistical outcome, that there's no really difference, even though the numbers may be different. Okay, so this is how to do this problem using Excel. So you can now do the problem using Excel. And I need for everybody that did not do the problem to go back and redo it and show me this kind of process. Now, if you have done it and you are not confident that you did it right, I will open the assignment for you and you can go and redo it, because once I grade it, you cannot go back. Okay? Now, I'm going to do the same problem using SPSS. Okay? So I'm going to do hypothesis testing. Two populations, SPSS. All right. So let's see how it's done. All right. So I'm going to save this file. I'm going to stop share. I'm going to pull up the data. Okay. Okay. Are you seeing my SPSS? Hello?
Yes.
All right. So I'm going to compare the price of houses with swimming pool and the price of houses with no swimming pool. As I said earlier, to do any analysis using SPSS, you must begin from analyze. All right? You must begin from analyze. I mean, depending on the procedure you're using, if you want to do descriptive statistics, frequencies, means, whatever, you use descriptives. Okay, you can construct tables here. So I'm going to compare means. Okay, there are other kinds of procedures here, regression and what have you, that we're going to do. So we'll compare means. But when you are comparing two populations, you compare means and you do independent sample t-test. Again, independent sample t-test. When we did confidence intervals, we use one sample t-test. So now we're doing independent sample t-test. So we're doing independent samples. Okay? So we are comparing prices of houses. All right? Now, what are the two groups? The two groups are houses with pool. Okay? Houses with pool, and we push them in there, and we define the groups. 0 for no pool, 1 for a house that has a pool. You say continue. Go to options. We are doing a 98%, which is a 0.01 level of significance. And we say continue. All right. And then you say, okay, abracadabra. Now, the abracadabra comes back and gives you see the same numbers we got using Excel? They are here, 202, 797, 231, 485, the same standard deviations, okay? And here, we have the summary statistics, which I'm going to copy. I'm going to copy that, and I'm going to put them into a Microsoft Word file and edit it before I post it, okay? You're not going to see what I'm doing there, but you will see me posting it into the PowerPoints when I get there. All right, so I'm going to stop this here. I'm going to pull up the PowerPoint slide. And so you saw the results, which I have edited. And those results are up here. All right, so now what you see now, do you see the same numbers that we calculated using SPSS? We saw the T of, this is actually the Z value. You see the Z value of 3.477 here? Hello, guys, are you there?
Yes, officer.
Okay. Do you see the same Z value of 3.477 that we calculated? Hello? Are you guys still there?
Yes.
Yes, we do. Yes, we do. My service was bad. Yes, we do.
Okay, so you see the Z value of 3.477 that we calculated.
Yes.
Okay. And you also see the mean difference of 28,687 that we calculated.
Yes.
Very good. So there are two ways you can use the SPSS output. Okay. You can see the confidence interval that we did. If the values of the lower and the upper confidence interval are all negative or all positive, then you reject the null hypothesis. You get it? You see the lower confidence interval is a negative number. The upper confidence interval is a negative number. Okay. If it goes from negative to positive, then you cannot reject the null hypothesis. If it goes from positive and ends up in positive, then you reject the null hypothesis. But if it goes negative and positive, then you cannot reject the null hypothesis. But you can also use the Z that it calculated for you, which is 3.477, and you compare it to your Z star. So it's much easier to use an SPSS processor to just do the problem and come up with an edited table like that, and then say, this is your conclusion. You get my point?
Yes.
Okay. So if now all future problems are going to depend on SPSS. Okay. But I need for you to do this because all future problems are going to be more complex. They're going to be more complex. They're going to be a little bit more challenging, put it that way. And so it will be much better for you to just run an SPSS. So when we come back next time, and I'm going to do it on Thursday, I'm going to run the SPSS. Now, if the SPSS is not available by then I'm going to do all the SPSS calculations and have you do the interpretation. Okay, so you have to learn how to read off these SPSS files. So I'm going to run SPSS and I'm going to coach you on how to read them. I'm going to provide you the guidance on how to read and interpret SPSS results. Okay, unfortunately, the COVID is making it difficult for us to be on campus. But if we were on campus, we're going to be in the lab and we will practice this SPSS. That is the industry standard. That is what you're going to encounter when you go out there. You're going to see a whole bunch of SPSS results. when you go out there if you don't do the calculation yourself. And for those of you who keep saying, I want to go to grad school, if you want to really go to a meaningful grad school, they're going to challenge you with things like this, where you have to do your own calculations and make your own decisions. And then when you get out, you have a better chance of getting a good job. Not just getting a job, getting a good job. And when you get, after you get a good job, then you might get a position. That's how to do it. All right? Okay. So does anybody have any other questions? Because I'm done. Any questions?
My question is, you said you are opening up all the assignments, right?
Yes, I will open
So
all
even
of them
the one,
up. And
even the one I gotta look. Okay, when are you gonna do that?
I'm going to do that between tonight and tomorrow. And if you don't see it between tonight and the end of the day tomorrow, send me an email.
Okay.
Okay.
Okay? I will open up all the assignments up to the 4th week. And I'm going to leave them open to the end of March. So there'll be no excuse for not going and redoing them and do them correctly, or not doing them at all. And if you don't do them by the end of the semester, you will not get a grade in this class. Because the assignments are easy. Okay? All right. Any other questions?
Professor, I want to talk with you.
Okay. So
About-
if you want to talk with me, then everybody else can say good night. And you see this lecture posted for you on YouTube. I'm going to give you the link and you can go and see it.
Okay, Professor. Good night.
All right. Good night. All right. So everybody, good night. So that I can talk with that Enid.
Yeah.
All right. So Bamisile, do you have any particular question?
Yeah, I have a question regarding my internship class that
Oh,
I'm struggling for.
okay.
And I don't know why it takes so long. I emailed everyone in the school, starting from my advisors and everyone, and I don't know what to do anymore. I mean,
Okay.
it's taking so long and it's so stressful.
I thought you already had an internship before you registered for the class.
No, I didn't have an internship and I still don't have an internship.
Okay. I'm going to do two things. I'm going to send you a list of what they call hot jobs. And I have to refer you to the career services. And I'm going to provide you two options. Okay. I'm going to stop recording because this is your